8.7. It's our final lesson with factoring. Okay. And this is what we call the special cases. Some of these special cases you can factor with the methods we've already used. Some of them, not so much. You need to know how the special case works. So we're going to talk about those today. And I'm not exactly 100% sure how I want to teach you guys. I always struggle with, what's the better way to teach this. But okay. X squared, well, no, let me back up. The first thing we're looking at are factoring perfect square trinomials. So if it's perfect square trinomials, if when you factor it, both parentheses match. That's what a perfect square trinomial is, when you have a parenthesis times itself. So the form that we're going to look for, a squared plus 2ab plus b squared, if the first and last term are perfect squares, there's a good chance it is a perfect square trinomial. And that'll make things a little easier on us. This is just the version when there is a negative in front of that middle term. Oh, excuse me. Now, as we look at x squared plus 6x plus 9, what if I say, okay, let's go back to what we learned back in 8.5 that you're kind of supposed to still remember. We'll see, right? So, back in 8.5 was when we factored the type that have nothing in front of the x squared. It's just a 1x squared. There's nothing in common. And if that's the case, we can go ahead and jump straight into two parentheses. The ones we worked on yesterday, they had something other than a 1 out front, which is what made life difficult. So let's talk about, okay, if we jump into two parentheses, what do you know about x squared? X and x, right? So x squared breaks up into x and x in each parenthesis, which that's what makes it easy, is because you don't have to, there's no number there that you have to try and figure out. Now, okay, you guys remind me, how do I figure out the numbers? What do those numbers have to do? I agree. It has to multiply to be one, add to be the other. I agree. Does that sound familiar? So if we talk, this is where I just tend to write P equals 9, S equals 6. So that's my way of saying multiply to be 9, add to be 6. If you'd rather write M and A for multiply and add, that might be better. So what kind of numbers multiply to be 9? 3 and 3? I mean, officially 1 and 9 also, but if you see it, you don't have to make the list. And if 3 and 3 is your first thought, oh, 3 times 3 is 9, 3 plus 3 is 6. Can you just go ahead and straight use that? Definitely. So 3 and 3, if it multiplies to be positive and adds to be positive, what kind of 3s are these? Both plus 3s. Okay. How could you rewrite that answer? X plus 3, quantity squared. And to be honest, MathXL might require that form at some point. I'm not sure. It wouldn't surprise me. It wouldn't surprise me. I can't say that I've gone through and played every single problem, but other option of how to do a perfect square like this. We can talk square roots. And when we talk square roots, x squared and 9, what do I mean square root of 9? Oh, you're fine. Just don't be surprised when I yawn back at you, because I'm going to be tired too. But what do we know about 9? Right, and 3 is the square root, because 3 times itself equals 9, right? So it's perfect squares because the square root of 9 is 3, because 3 times 3 is 9. Up here, the square root of x squared is x, because x times x is x squared. So based on the fact that x times x is x squared, and 3 times 3 is 9, if you can watch for that, that's going to help you a little bit. Especially when we get into bigger numbers. You know, you didn't have to catch that there, but... Okay. Try the next one. Which it's still not too bad. X squared minus 14x. 7 times 7? We're going to have to deal with the signs, aren't we? We'll get there in a moment. But does that make sense? 7 times 7 is 49. And 7 plus 7 is 14, isn't it? Okay, so we just have to get the signs to work out. You can also think about the fact of the square root of 49 is 7. And I don't necessarily know which way Jacob thought about it, but, you know. Now, if I set up in 2 parentheses for a moment, x squared breaks into x and x. We already set our numbers. We're going to break into 7, 7. It multiplies to be positive, which means my signs are the same. Both positives or both negatives. It adds to be negative 14. So, both signs are negatives. Look at that. I'm trying to hold a yawn back here. Now, Math Excel would probably prefer you put x minus 7 squared. Okay. That's probably the easier type, right? So let's look at the next one, which is a variation of this type. Can't hold back anymore. Okay. 9x squared plus 24x plus 16. This is where some of the methods we're talking about really come in handy today. It's just better if you just get it out and get it over with. It really is. Because this one's a little more difficult because it's not just x squared, right? If it was x squared, we can always just say x and x. This one, well, we could go back to yesterday's method where we have to do product of AC. But yuck, because then you're doing 9 times 16, which I think is 144. Yuck, right? That's not very, pretty. Other option. Okay. Look at your first and last terms. What do you notice about 9 and 16? They're both what I would call perfect squares, meaning I can take the square roots of them. Yeah. So let's think about this. What is the square root of 16? 4. So if this works out right, we're going to put a 4 at the back of each parenthesis. 9x squared. What is the square root of 9x squared? You went too far. 3x. Because what times itself, right? To get 9, it's 3 times 3. To get x squared, it's x times x. So right there, the 4 and the 3x are going to be the front of each parenthesis. So 9x squared breaks into 3x and 3x. 16 breaks into 4 and 4. If it multiplies to be positive and adds to be positive, my signs are positives. Now, the one thing we didn't really talk about, because that's your answer, folks. Other than rewriting it, that's your answer. You're done right there. The one thing we didn't really talk about is the 24x. And it's there, I promise. Okay, if you were to FOIL this, right? 3x times 3x is the 9x squared, right? Then you do outsides. 3x times 4 is going to be 12x, so there's half of it. Then when you do your insides, 4 times 3x is 12x. There's the other half of it, right? Because 12x and 12x is 24x. And then 4 times 4 is your 16. Now, you have to be very careful because it technically it doesn't always work. What we can use to check ourselves is the idea of if you do your 3x, right, times your 4, and you do times 2, because there's always going to be 2 of something when you FOIL. You do 2 times 3x times 4. Well, 2 times 3 is 6. 6 times 4 is 24, and there's an x. This 24x should match with the middle term. So that's kind of a self-check if you want. Okay, and this one, you know, if we had to do product of AC, it would be doable. I really would not want to do product of AC on the next one, though. 16 times 81 is a big number. Then to find the pairs that multiply to be that, I'll pass. So, what do you notice about 16 and 81? They're both perfect squares. And that's going to work to our advantage. What is the square root of 81? 9. What is the square root of 16m squared?
4.
Just 4m.
Yeah.
So right there, those are the pieces you need. 16m squared breaks into 4m and 4m, because it was the square root that you can't see up there. Square root of 81? 9, so that's going to break into 9 times 9. If it multiplies to be a positive, 81, they're both positives or both negatives. If it adds to be a negative in the middle, both negatives. So 4m minus 9 times 4m minus 9, which can be rewritten as 4m minus 9 to the second. You could say squared as well. Does my middle term make sense? It's not that you have to write it down, but it's always a good thing to check. And if my middle term makes sense, it should be 2 times my 9 and my 4m, right? And 2 times 9 times 4 is going to be 72. 72. And I guess I should have used negative 9, because we ended up using negative 9 there. But, you know, I'm just trying to check, does the numbers work? Does it make sense? Okay, so when you see those perfect squares on either end, 2 parentheses, the same, you just have to decide are they both positives or both negatives. And that's when there's a middle term. Now, the other type we're going to look at is factoring a difference of 2 squares. As we factor a difference of 2 squares, you're going to notice that both pieces are perfect squares. Okay? And that they are being subtracted. And if they're both perfect squares and being subtracted, then you can do the square roots. The difference from last time is you have a plus and a minus in the middle. That's the only difference. Okay? So let's try v squared minus 100. Can you do the square root of 100? Yeah, I was saying, I'm assuming that's what Mikaylee was just checking. I just had a feeling that she's a step ahead of me in checking that. That's fine. Now, the square root of v squared. Can we do the square root of v squared? Yeah. V times v is v squared. So they're both perfect squares, and there's a minus sign. So guess what? 2 parentheses. What does v squared break into? V and v. What about 100? 10 and 10. How do you multiply to get minus 100? We need one of them to be positive, one of them to be negative. It does not matter which. I wrote v plus 10, v minus 10. If you reverse that, that is perfectly fine. Huh? Yep, it's fine. Now, are we okay with that? Yeah. You can't combine because they're different signs. If we were to FOIL it out, what would happen is we'd have a negative 10v and a plus 10v in the middle. Well, negative 10v and plus 10v add to be 0v. Okay. So, moving on. Practice the next one. 25d squared minus 64. You see some square roots there? What is the square root of 64? 8. Oh, that's good. That works. What is the square root of 25d squared? Square root of 25 is 5. So it's going to be 5d. 2 parentheses. Okay, how does 25d squared break up? 5d and 5d. How does 64 break up? 8 and 8. How do you multiply to get minus 64? One negative, one positive. That's the final answer. Okay, 2 more examples. 12t squared minus 48. What? Yeah. Can you do the square root of 48? Can you do the square root of 12? No. Okay, so let's back up. I'm not doing what I should be doing as your teacher. I haven't been asking this one startup question every single problem. I tend to forget. Anytime you're doing any type of factoring, technically your first question should be, is there any type of GCF, greatest common factor? Is there anything that 12 and 48 both divide by that we could factor out ahead of time? Oh, they both divide by 12? Oh, well, let's see where that puts us then. So if I divide these by 12, realize that 12 is going to go where? It's going to go out front, yes. 12t squared, if I divide that by 12, I'm left with just 1 or 1t squared. Minus, what's 48 divided by 12? 4. Okay. What do you know about t squared minus 4? Can you take the square root of 4? Yeah. So now we can factor into our two parentheses with opposite signs. Now what am I going to say about the 12? Carry it down. Don't lose it. We need to know what? Okay. T squared is going to break into T and T. What about 4? What is the square root of 4? 2. So if square root is 4, we're going to write this as, or square root of 4 is 2, we're going to write this as 2 and 2. What about signs? 1 negative, 1 positive. So I wrote 12 times t minus 2 times t plus 2. Okay. Huh?
I was reading the poster.
Oh. Yeah. How about one more math problem? Okay, what do you know about 12x squared minus 3? Don't do the thing. So I think what she's trying to say is they don't have, they're not perfect squares. They don't have square roots. But they, okay. They both divide by 3, so what do I do with that 3 they divide by? Slap it down. Okay, I slapped it down. And then 12x squared divided by 3 leaves me with 4x squared minus 3 divided by 3, 1. So now the question is, can I take those square roots? Can we do the square root of 4x squared? Square root of 4 is 2. So square root of 4x squared is going to be 2x. Okay. You could call this one the toughest one or the easiest one. Square root of 1. 1. So we can do this, right? Okay, so carry down your 3, 2 parentheses. 4x squared breaks into 2x and 2x. 1 breaks into 1 times 1. How do we multiply to get a minus or negative 1? 1 positive, 1 negative. Okay, guys. Lesson 8.7 in Math Excel is what you need to look at. Except, if I'm not mistaken, I might have to make it available.